E-Chemistry class, Fatima Convent High School, myself, Dipali. Chapter 3, Metals and Non-Metals, Class 10th. Let us start with the third session of this topic, where we are going to study how do metals and non-metals react, and about ionic bonding and ionic compounds. After studying the physical and chemical properties of metals and nonmetals, we are quite familiar with the behavior of metals and nonmetals with various substances and various reactions of metals and nonmetals. Now, how do metals and nonmetals react? In the above activities, we saw the reaction of metals with a number of reagents. Why do metals react in this manner? Let us recall what we learnt about the electronic configuration of elements in class 9th. We know that electronic configuration is the base on which the structure and chemical reactivity and physical properties of any substance is based. So, the metals and nonmetals behave in the above manner because of its electronic configuration or the presence of electrons, protons, and neutrons in varied ways in their atoms. We learned that noble gases, which have a completely filled valence shell, show little chemical reactivity. We therefore explain the reactivity of the elements as the tendency a completely filled valence shell. Let us have a look at the electronic configurations of noble gas and some metals and nonmetals. The sodium metal has one atom in its outer shell. If it loses that electron from its M shell, then its L shell must become the outermost shell and will have a stable octet. The nucleus of this atom still has 11 protons, but the number of electrons have become 10. And so the positive charge given increases and positive charge giving us a cation of sodium, that is Na+. On the other hand, chlorine has 7 electrons in the outermost shell. To attain the stable octet, it requires one more electron to complete its octet. If sodium and chlorine were to react, the electron lost by sodium would be taken by chlorine. So let us see some of the electronic configurations. Noble gas like helium has atomic number 2 and configuration is 2. Neon atomic number 10, configuration 28. Argon 18, electronic configuration 288. Sodium 11 281. Magnesium 12 282. Aluminum 283. Potassium 2881. Calcium 2882. So we can see there is only one electron, 2, 3, 1 and 1. So it will have valency plus 1, plus 2, plus 3, plus 1 and plus 2. Whereas non-metals have the tendency of accepting the electrons and becoming negatively charged ions like nitrogen 7, 2 and 5. So it is minus 3. Oxygen 8 atomic number 2 and 6, so minus 2. Fluorine 9, so 2 and 7, that is minus 1. Phosphorus 15 285, minus 3. Sulfur 16 286, minus 2. Chlorine 17 287, minus 1. So we can see that the metals always form positive ions or they are electropositive. And non-metals are electronegative. because of which they generally form the ionic bonds. The special example or the commonest example of this is sodium chloride. Let us see how the molecule of sodium chloride is formed by the combination of atoms of sodium and chlorine. Now we understood that the sodium and chlorine were to react, the electrons lost by sodium would be taken up by chlorine because sodium has one electron extra and chlorine lacks one electron. So after gaining an electron, the chlorine atom gets a unit negative charge. Because its nucleus has 17 protons and there are 18 electrons in its Kl and M shell. This gives us chlorine anion Cl-. So both these elements can have a given and take relation between them. So Na gives Na++ electron to form sodium cation. Same way chlorine plus electron gives Cl minus, that is chlorine anion. If you see the Lewis dot structure of this substance, you get Na plus 1 and Cl minus 1. They combine to form NaCl. This is how a molecule of sodium chloride is formed. Sodium and chloride ion being oppositely charged attract each other and are held by strong electrostatic force of attraction to exist as a sodium chloride. It should be noted that sodium chloride does not exist as a molecule but as aggregates of oppositely charged ions. Let us see the formation of one more ionic compound, magnesium chloride. Magnesium gives Mg plus 2 electrons. It has 2 electrons extra. And Cl takes that 1 electron to form Cl minus. Now here, one atom of Mg has 2 electrons extra, which it will give to one each of chlorine atom to form MgCl2, which is an ionic salt. The compound formed in this manner by the transfer of electrons from a metal to a non-metal are known as ionic compounds or electrovalent compounds. Can you name the cation and anion present in Mg and Cl? 2, that is Mg is plus 2 and Cl is minus 2. Now let us see the properties of ionic compound based on this characteristic. To learn about properties of ionic compound, let us perform the following activity. Take a sample of sodium chloride, potassium iodide, barium chloride or other salts from the science laboratory. What is the physical state of these salts? They are generally crystalline solid. And take a small amount of sample on a metal spatula and heat directly on the flame. Repeat these other samples. What do you observe? Color of the flame when NaCl is heated is yellow. So you can say NaCl is solid, Ki, BaCl2. All are solid in state. This is yellow flame, light purple flame and pink to white colored flame is obtained. Now if you check the solubility, then they are soluble in water. If you check in petrol or kerosene, they are not soluble. If you check the conductivity, then all are good conductors. And their nature is ionic. So, from this activity, we can come to a conclusion for the properties of ionic compounds. And if you see the melting and boiling point of these ionic compounds, then melting point is very high, that is 1074, and boiling point is 1686. Lithium chloride is 887 to 1600. Calcium chloride is 1045 to 1900. Calcium oxide is 2850 and 3120. And MgCl2 is 981 and 1685. That is a very high boiling and melting point. Now let us summarize the properties of ionic compound. You may have observed that the following general properties for ionic compound. The physical nature. Ionic compounds are solids and are somewhat hard because of the strong force of attraction between the positive and negative ion. These compounds are generally brittle and break into pieces when pressure is applied. So, we can say they are brittle solids and crystalline in nature. Melting and boiling point is very high, as we already saw in the table. The reason for this is the energy required to break the strong interionic bond is very high, and so their melting and boiling point is high. Solubility. They are generally all soluble in water but insoluble in solvents like kerosene and petrol. Conduction of electricity. The conduction of electricity through the solution involves the movement of charged particles. A solution of an ionic compound in water contains ions which move to the opposite electrode when electricity is passed through. The ionic compound in the solid state do not conduct electricity because movement of ion in the solid is not possible due to their rigid structure, but ionic compound conduct electricity in molten state. This is to be very clearly noted. It is possible in the molten state when the electrostatic force of attraction between oppositely charged ions are overcome due to heat. Thus, ionic compound move freely and conduct electricity only during molten state. Is this topic very much clear to you? Thank you for now.